Hello all, welcome to Ambari Cloud YouTube channel, part of Ambari Cloud LLM class training. In this video, I'm going to walk through about embedding. What is embedding? Embedding is way to represent data like text, images, or other objects, or like videos, as a dense vector in a high dimensional space. We'll look at that. So basically, when you convert a text or video or images into a matrix format, then it's easy for machine learning models, right? So you and I think in English, but machine learning models need it in a vector format, which is basically a n-dimensional matrix, or maybe tensors you call. Then it will still maintain the actual meaning of your text when you want to do a reverse of it. So you take a text, it convert into the multi-dimensional based on your data anyhow, into a vector format. And then it allows you to do easily similarity sets with similar documents, because here we are comparing numbers to numbers, right, in an n-dimensional way. Then it also helps to understanding clustering and classification. So we look at how to convert our text into a vector embedding format. Then later we're going to store these embeddings into a vector store. Okay. So vector representation is basically you're converting word or sentence or document or image into a numeric array of vector of fixed size. There are different sizes based on your vector, the conversion, the model, you will get a different size of your vector. For now, I'm not going to deep dive, the ML side of it, basically how to define a tensors and then create your array, convert into tensor and then vectors and all the stuff. Maybe I will set up separate class or separate video understanding about, how to build your n-dimensional arrays or vectors or tensors. Then the advantage is basically you store in a vector space, and then you are comparing with numbers, and then you can do similarity sets, or you can even build the clusters or classifications based on how the data is spread out. Okay. The another thing is to store raw data, right? You need more space, but with the embedding format, it does the dimensionality reduction. Again, it is beyond this class about the dimensional reduction. I suggest if you guys dive into how to do dimensional, we will have one of the example. We'll do that, but more details about the dimensional reduction. How to convert the actual math of it, right? Vector multiplications and all the stuff, right? So it allows then, but still it keeps your meaning of it, right? So what is the common use of embedding, right? Of course, in LLM model, we're going to send these embeddings to vector store, and then, it will, process on it instead of sending the raw data. So we're going to store all this raw data into vector format. And then image also, we're going to store in vector format, and then of course videos. Every model has different vector size, right? We can look at those. So here, imagine the sentence, the cat is on the mat, felon is lying on a rug. They are almost same, right? But each has its own vector, but they are nearby. So they are very close when you in the embedding space. But if in a raw, they are different, looks different. But when the meaning almost near in the embedding space, and they stay near, we will look at one of the graph. Okay, so you have for example, you have an input, then you're going to use OpenAI embedding or we're going to use mostly OpenAI. We're not using word to vector transformation. So it converts into a number, right? The number of, depends on the model, you will get the size of the vector. We're going to look at the shape of the vector also. Then what are the use, right? Definitely in the RAG architecture, retrieval and argument, and then the generate architecture, right? So we're going to store all these documents in the vector format, and we already know how to create a document. So we can store in the vector format, and then we can do search on in vector format. So basically, let's say when it search, let's say I want to know orders, right? Then we have all our orders information, or I want to know the addresses or something. Then address is also your query is converted into vector format and does a vector search. Then it's basically similarity search. Then also we can build clustering classifications, right? So let's say you have a data And then you want to know how the data is being clustered, k-means, right? You can build a k-mean, or you want to know how the data is being classified, then you can build those machine learning using embedding, right? In this class, I'm not planning on clustering and classification, but maybe I will set up later one of the class. I used to teach ML, but in this class we will stick with the LLM. Okay, how to do that? Embedding. So you have a document, you're gonna split it. Okay, you have a pages, then you're gonna do chunks, right? And then you're gonna use OpenAI embedding, right? So this is the library we will be using it. So of course you need to have a key with OpenAI. So once you set up the key and then you OpenAI embedding, right? Then if you look at the embeddings, then it will tell you what are the properties of this embedding. What is the size of the token? What is the size of the dimensionality it will provide? Basically, whatever the document you gave it to you, it will convert into what is the size of the embeddings. And then of course, once you have the embedding object, you're going to do embed query of given a text, then you will get the numbers, right? So let's say, you can also send, this is a query here, simple line here, but you can also do embed documents, right? Then this is basically a list of text, then it will be converted into documents and then you will get the embeddings. Okay, so let's get into very quick, right? And then I'm going to read document. We already learned about how to read a documents and then split into pages, split into chunks, right? Then we have 3 chunks here. Then here I'm going to OpenAI embeddings, right? And then I'm going to the chart OpenAI, or you can use the OpenAI, depends. Doesn't matter for our example here. Now, if you look, now if you see the what model, this is a default model is using, but you can specify what model you want to use, right? So it is using text embedding. And then if you go to the chunk size, you have to use chunk size of 1000. Then if you look at how many times retries and then embedding it will provide all the details of your embedding, right? So every time these values will vary between model to model. So you have to look at that one. I'm not defining since it is default dimensions here. So let's try that one. Okay. So here I have a text, right? Then I'm going to do embed query. Then you look at this one. This is converted into big array, right? So if you look at here, this is a one list. This is basically now if you do reverse, then you will get this value. Okay. So let's dive into a little bit other examples. So now I have a small documents, right? And now, so this is my embed document, right? This is my embed, right? Now let's say I have a page content, right? And then, I convert into embed document using embeddings, right? Then we got the embed, right? Now, if you look at this embed here, right? Then look at how the values are here, right? But I want to know, right, how this is being actually looks like in a. So here I'm going to convert, right, this embed into an array, right? So let's convert the embed. Now, if you look at here, it's difficult to tell what. So you will convert into an array, then run the shape. Now it is a, right, 91 by 1536 shape array. That is so it has a 91 rows and then 1536 column array. Now if you look at, it's time to go into a deep dive of how this document's being actually converted. Let's go here closely somewhere, it will close the list. Because this is we'll come back. Now let's take this one, right? Simple embedded documents. Now embed one, right? Now if you look at the length of embed, right? Because it has 1, 2, 3, 4, 5 rows. So that means 5 objects, right? And then Then let's convert this one, right? Now same thing, 1536. That means it has each row, right? If you look at here, each row, right? It has a 1536 values, right? So this is, look at here, each row. This is one time. So this is 1536. If you put it as, if you convert into whatever format it is, but it has a 1536 values for each value of your string. This string has, right, 1536. This is a list, right? This is 5 rows. So that means row 1, right? Row 2, row 3, row 4, row 5. So because it has it. So now this is one embedding, right? And when we store all this information into vector store, yeah, it will store in a dimensionality way. So now let's try here. Just look at one row. Okay, one row is 15.6. Because there's one row, right? So that's why no, we're not defining in the car. But then you can convert into matrix format, whichever way, it's an n-dimensional way, you can do that too. Now if you look at this array, yeah, this whole array here thing. Now if you can look at in this array, I want to know what is the individual value. This is a value. So your individual text is converted into 536 dimensions, right? Or vectors, sorry, I would say. Then it is a one row, and this value is stored in your vector store. And when you do search on it, right? So high there, then their high are almost near, they will be related to stored here, right? Oh, hello, what is your name? And then, yeah, they may be stored in different places, but this is how the vectors are converted. Okay, so let's get into one more example. Actually, the same. Now I want to show that in a different way. Let's get into. Okay. So here my strings, right? Then if you look at here, this is my data. Then I'm going to, okay. Then here I'm using an OpenAI instead of a OpenAI embedding. So here OpenAI embeddings create, then internally is using this transformer model, and then I want to convert. Now let's run this one. Okay, so here now it takes each text, right, and then send it to this model, right? Then I got the embeddings, then I got the embedding array, right? So then finally I got the final. So this embedding I converted into an array. Now if you look at here, okay, how many rows I have? 7, right? So 7 rows, right? And shape of 1530. Same thing previously, whatever the previous demo we saw that. So embeddings, right? Then each row is like this. Okay, so I want to graph this, right? I want to graph this, but look at it has a 1536 points for one row, right? And then, but I want to show in 2-dimensional graph, but actually it should be shown n-dimensional graph, but is then not beyond, is beyond this class, right? But I want to show this as two-dimensional, right? So there is a PCA model, right? Basically what it does is it decomposes into two-dimensional, right? You can do n-dimensional also here, but right now we're going to convert the entire data into a dot. So we're going to convert this into a dot, two-dimensional. Dot is two-dimensional, right? X and Y curve. So we will convert your each row of 1536 points into a dot, right? Now let's convert that. Okay. Now look at the shape. Now it is a 7 by 2. You see, number of rows are still 7. Now it's two-dimensional, right? So 756 values now become 2. Now what I'm going to do is I'm going to graph it. So now look at this one. These are I have other data also. So if you look at here, these are the data is graphed into single values. Okay. because you take this value in X and Y, and then this is one of the string. So look at some data very near, some data, and this is too far. They're not, they are kind of similarity sets. Or if you look at, this is kind of a cluster. This is one kind of cluster, and okay, maybe they are kind of cluster, but this is by itself, and this is one kind of cluster. So when you do such, let's assume this is hello, hi there, then you will get all these three, maybe this 5, but definitely you won't get these in the similarity sets. And this is how data is stored. But I'm showing your entire one string as a dot in a 2-dimensional format, but actually it is stored in an n-dimensional format, right? Because it has 1536 points. Okay. And so definitely you can try in a 3-dimensional, but I will show that one in another video, how this data is actually stored in a, then it goes to beyond ML class. So here, same thing. I did maybe one more time. So same data again. So this data here, this data together. That's why if you look at, I have the reds are from the previous one, then greens are the another one. So I have total 5 here, then 7 there. So that's why if you see here, okay, if you see red 1, 2, 3, 4, 5, then 3, 4, 5, 6, 7. Okay, I'm graphing everything. So, and this is how the data actually stored in your vector store. Of course, it still rows values if you actually can see it in PG vector actual, but it is a vectorization. So when you search a hi there, and think about if these three, right, a hi there, a hi, hello world, maybe these three, these two and this one may be related here. Then the similarity sets will give it to you. So this is how your text is converted into embedding and stored. Now I'm showing the data in a 2-dimensional format. And then when you do a similarity search, then your index or vector index will return these 3 values, right? And then if you ask for this, then you maybe get these 3. If you ask for this, you may get these 3, or maybe these. But if you ask it, you get only one value. And so if you see the, right, kind of in a cluster, right? This is one cluster and one cluster, one cluster, one cluster, like that. This is then all related data together, right? So this is how you do cluster analysis too. And then next is k-means you can build. Okay. So this is how you learn about embedding. And as I said, I will show the data, how it is stored when you go to the vector store. And also I will show n-dimensional graphs later. But right now I'm using PCA decomposition of 2D visualization. Right? Any other question? Send me an email. skondapalli@ambaricloud.com. So as of now, we covered documents and chunks and overlapping, and then embedding. So keep practicing. Then next video, we're gonna talk about vector store, right? Vector DB. Okay. Thank you.